Hello children, today we are going to discuss about the electric circuits. Electric circuit is a closed continuous conducting path which can be obtained by connecting the conducting wire to a bulb, to a switch and then both the ends of the wire we can connect to the positive and negative terminal of the battery. If there is no break in the wire, then the path is continuous and the circuit will work. The bulb will glow. Now, let us see the symbols first. Symbols of the electrical components. See, this is a cell, a positive and negative terminal of a cell. If you connect more than one cell, we obtain a battery. We form a battery. Then connecting wires, the wires which are used to connect the different electrical appliances like a bulb, a switch, a battery. When they are joined to each other, they are joined with the help of the connecting wires. Now wire joint. When we have to connect more than one thing at a point, then we use a wire joint. Then this is a overlapping wire. The wires are not touching each other. Just to show that the wires are overlapping, we have made this. See, suppose if I make this, then can you recognize where the wire is going? This way or this way or this way? So we use this kind of a symbol for representation the overlapping of the wire. Now next is a fixed resistance. We also call it as a resistor. Then variable resistance, we call it as a rheostat. This is used in the circuit for changing the current without using the battery eliminator to change its potential. Then ammeter. Ammeter is used to measure the current. Voltmeter, it is an instrument used to measure the voltage of the circuit. Galvanometer, it is an instrument which is used to detect the current, not measure the current, detect the current. Ammeter is used to measure the current. Galvanometer is used to detect the current. Now comes the open switch. Open switch is when the circuit is discontinuous. If the two ends of the switch are going to meet, then only the current will find its path to flow. See, this is a symbol of open switch. Then you have a closed switch. The two are meeting together. The current will flow continuously. This is a switch, closed switch. Then bulb. You can see the symbols of the bulb. Electrical bulb is represented like this. Now we are coming to circuit diagram. See, I have a battery over here. The positive terminal, the negative terminal of the battery. I have connected a ammeter in series to a circuit, a resistor. It can be anything, a bulb, a fan, or any other kind of a load. Over here with this, I have connected a voltmeter in parallel to it. Voltmeter is always connected in parallel to the circuit. See, and then the wire is coming back to a switch. With the help of the switch, you can switch on, switch off the circuit, and then to the negative terminal of the battery. This is how the circuit is completed. If you switch off, then the circuit will become discontinuous. There will be no contact between the two wires and no current will be flowing. You switch on, the contact will be there and the current will be flowing through the circuit. Ammeter will measure the amount of current. Voltmeter will measure the potential difference. Now let us see direction of current. As in the diagram before, just now I have shown you the direction of the current is from positive terminal to the negative terminals. This is the conventional current, direction of the conventional current. We know that in a circuit like this, the flow of the electron is from negative terminal to the positive terminal. but the direction of the current is taken opposite to the direction of the electrons, that is from positive terminals to the negative terminal. Now we have the other form of direction also, that is electronic current. See, some people were of the view that when the electrons are responsible for the flow of the current, why not the direction of electron be the direction of the current? That is not false. Their concept was also true, but since we are following the same from before, we have taken the direction of the current to be positive to negative. And now if you say electronic current, that is from negative to positive, that will also be correct. Now coming to the flow of current. Flow of current. If you take a wire randomly like this without connecting a battery, the free electrons in this metallic wire will be flowing randomly here, there, anywhere. Okay, but if you connect it with a battery, what will happen? A potential difference will be developed across the wire, and the electrons which are generated at the negative terminal will flow from negative to the positive end. Okay, they will be attractive towards the positive end, and this will give rise to a electric current, and the direction of the electric current will be from positive to negative terminal as we say it. Now coming to the Ohm's law. At constant temperature, current flowing through a conductor is directly proportional to the potential difference across its end. Means if you maintain the temperature, then in any electric circuit, the current flowing will be directly proportional to its potential difference. That is, I will be dependent on V. If I increases, V increases, V increases, I increases. If both, so V equals to Ri, where R will be the resistance, a constant quantity for a given material. We can say resistance of a conductor is a property of a conductor due to which it opposes the flow of the current. That is, it is a hindrance in the flow of the current. If the resistance of any wire is low, we call it a good conductor. If the resistance of a wire is high, we call it as a resistor or a resistance wire. Generally we say R equals to V upon I. The SI unit for resistance is ohm. From the formula we have 1 ohm equals to 1 volt upon 1 ampere. Now if we see the graph for this, the VI graph is current to potential. We take potential along the x-axis, current along the y-axis. It will be a straight line. Now factors affecting the resistance of the conductor. The length of the conductor is going to affect the area of cross section of the conductor, the nature of the material, and the temperature. See, length of the conductor, more the length of the conductor, more will be the resistance. More the area of cross section of the conductor, less will be the resistance, as with each the electrons are going to pass through that cross sectional area. The nature of the material, if you are using silver, silver is a very good conductor, best conductor of electricity. Okay, so the resistance will be very, very low. And if you are taking nichrome, the resistance will be very high. Then temperature, more the temperature, you increase the temperature, the resistance will be low. Why? Because the electrons will be generated, they will be moving more fastly. Then resistivity. From here only we can see R is directly proportional to L. R is inversely proportional to 1 upon A. If we join both these equations, we can say R is directly proportional to L upon A. Remove the proportionality sign. We are introducing one constant that is known as rho. This is the symbol of rho. You can see this. This is the symbol of rho. R-H-O. If L and A both are unit quantities, take L to be 1 meter, take area of cross section to be 1 meter square, then rho will be equal to R. and over here in this case it will be called as resistivity. SI unit of this will be ohm meter. See, length is meter, A is meter square. So if you cancel this out, rho will be equal to, meter will go this side, this will be ohm meter. So unit of this will be ohm meter. Resistivity is a characteristic quality of any material. It does not depend upon length and cross-sectional area of that material. Understood, children? Now in the next segment we are going to discuss with the numericals of Ohm's law and resistivity.